Okay, let us move. Some of you are not following my instructions. I see still their audio is off, so they won't hear me. But let us start. So this is what I had prepared for you. I hope you are all able to see the notes on your screen. Our notes on carbon dioxide. I'm just reminding you, I would have actually started from carbon, but I felt this is what is more important. So let us start from here. Occurrence of carbon dioxide, we remember that it has a percentage of 0.03% in the atmosphere. It has a percentage of 0.03% in the atmosphere. Then when we know that, we can now look at its laboratory preparation. I've always told you in class that when a question is asking for laboratory preparation of any gas, you need to know, number one, raw materials or substances from which the gas can be prepared. After knowing raw materials, you need to know a catalyst. There are some gases which are prepared by using a catalyst. After knowing that, you need to know the drying agent, because I've always told you you should never expect a question where we are asking you to prepare a wet gas. So you must know the drying agent of each gas. And after drying the gas, definitely you will need to know how to collect the gas. That means you need to know the method of collection of the gas. So let me take you through. For carbon dioxide, the substances that we use to prepare, we use dilute hydrochloric acid. Take note, the acid must be dilute. We use dilute hydrochloric acid and calcium carbonate. Calcium carbonate in the textbook, sometimes it is called marble chips, but it is the same thing. You should not get confused. So calcium carbonate is sometimes called marble chips. So don't get confused about that. So after knowing that, we use calcium carbonate and dilute hydrochloric acid, you give us the observation, although sometimes we don't mark this when we have asked for the preparation. But from our knowledge of acids and bases, we know that whenever you add a carbonate, if you add an acid to a carbonate, there is always evolution of gas. The colorless gas is given out, and that colorless gas is carbon dioxide. So we are saying effervescence occurs as a colorless gas is given off, and the colorless gas is carbon dioxide. Now, when you are preparing a gas, whether we have asked for the equation or not, and the question is saying describe how a gas is prepared, please write the equation. Please write the equation whether we have asked for it or not. Endeavor to write the equation. Endeavor to write the equation whether we have asked for it or not. So our equation is here: calcium carbonate plus hydrochloric acid, and we form calcium chloride. This is always the source of error for most of you. You forget that calcium has a valence of 2. So calcium chloride, the formula is like this: plus carbon dioxide, then plus water. Take note of that. Then the states: calcium carbonate is a solid, hydrochloric acid is aqueous, then calcium chloride formed is aqueous, carbon dioxide is a gas, and water is a liquid. Now, We have now given the raw materials from which the gas is prepared, that is calcium carbonate and dilute hydrochloric acid. We have written the equation. So what do we need now? We now need to give the method. How is the gas collected? The gas is collected by no before we collect the gas, we now talk about how the gas is dried. Carbon dioxide gas is dried by using concentrated sulfuric acid. This word must be there, concentrated. Sulfuric acid is only a drying agent when it is concentrated. If it is not concentrated, then there is nothing that is going to happen. So the gas is passed through concentrated sulfuric acid for drying. And we give a reason. Why do we use concentrated sulfuric acid to dry the gas? The reason is very simple. Because carbon dioxide gas is acidic gas. And since it is acidic, it does not react with concentrated sulfuric acid. Sulfuric acid also being an acid, it cannot react with an acidic gas. Take note of that. It is very important. It cannot react with acidic gas. Let's move on. After drying the gas, what happens next? You collect the gas. How is the gas collected? Carbon dioxide is collected by downward delivery. Downward delivery. It is collected by downward delivery because it is denser than air. Now, I want you to look at what I have written for you. Where I have underlined, wherever I have underlined, you know that that one is a marking point. And when you write it, we shall give you marks. Wherever I have underlined, you know that that is a marking point. And when you have it in your work, we shall give you marks. Now, I want to talk about something which is not here. Remember, carbon dioxide gas is not prepared using sulfuric acid. We cannot use sulfuric acid instead of dilute hydrochloric acid on calcium carbonate. And the reason we talked about it, remember, it is very simple because when you use sulfuric acid, instead of forming calcium chloride here, it will form calcium sulfate. And calcium sulfate is sparingly soluble. It is sparingly soluble in water, so it will form a coating on the surface. So the calcium sulfate which will be formed here will form a coating on the surface of calcium carbonate, and the acid will no longer access the carbonate, so it will stop the reaction. Take note of that. When you use sulfuric acid instead of hydrochloric acid to prepare carbon dioxide, what happens is it will form calcium sulfate, and calcium sulfate is sparingly soluble. So it will form a coating on calcium carbonate, and that will stop further reaction. Why will it stop further reaction? Because calcium sulfate formed will form a coating on calcium carbonate, and the acid will no longer access the carbonate to react. So the reaction will end there. So I will ask you to go to your books and the textbooks and draw the diagram. We drew the diagram in class. Just go and look at it and revise it using the textbooks. So the diagram, I'm not going to draw it for you, but remember all the points that we talked about on the diagram. Do not label the diagram using formula. Do not label the diagram using formula. And even when you are writing statements like this, don't put the formula. Only use the formula if you are writing the equation. I'm warning you on that. Let's move on. Chemical reactions of carbon dioxide. Let me take you there. With magnesium, this is one of the commonest reactions of carbon dioxide. With magnesium, what happens when carbon dioxide is reacted with magnesium, is treated with magnesium? First of all, what we need to know, or what we need to remember, is that carbon dioxide does not support burning. But however, when a piece of burning magnesium is lowered in a gas jar of carbon dioxide, the magnesium continues burning. What is the reason for that? Carbon dioxide is denser than air, so it will displace oxygen. So let's talk about that. When a piece of burning magnesium is lowered into a gas jar containing carbon dioxide, it continues to burn, forming black specks of carbon. This is the observation, and a white solid. The white solid is magnesium oxide. So we may ask, state what is observed when a piece of burning magnesium is lowered into a gas jar containing carbon dioxide. We are saying your answer will be, it continues to burn. I say I've underlined it. Whatever I underline, you know that I will give you a mark if you present it in your answer. It continues to burn. This is a marking point because we know carbon dioxide does not support burning. But with magnesium, it continues to burn. It continues to burn, forming black specks of carbon mixed with white solids. So these are the observations: black specks and white solid. The white solid is magnesium oxide. You can see it in the equation. And the black specks are for carbon. This equation, and as you will see when I give it to you in the assignment, many of you will fail it because you are on hurry, you forget to balance these two here. It should always be there to balance oxygen. You first put the 2 to balance oxygen, because oxygen is here at 2, and on the right hand side it is 1. So you put 2 to balance oxygen, and you put 2 to balance magnesium. How can we explain this reaction? Why does magnesium continue to burn in carbon dioxide? The answer is magnesium. You know, when we look at reactivity series, magnesium is higher than carbon in reactivity series. So magnesium displaces this carbon from its carbon oxide of carbon dioxide, and it forms magnesium oxide. So we can say magnesium displaces carbon from its oxide because it is higher in reactivity series, forming magnesium oxide. So magnesium is higher than carbon in reactivity series. Another person can say magnesium is more reactive than carbon, and therefore displaces it from its oxide of carbon dioxide, forming magnesium oxide, which is a white solid. Another explanation, another way someone can say magnesium reduces carbon dioxide, because remember, reduction is the removal of oxygen. Reduction is the removal of oxygen. So magnesium reduces carbon dioxide. In other words, magnesium removes the oxygen from carbon dioxide, forming magnesium oxide, which is a white solid, and carbon, which is black. That is another explanation that someone can give. So take note of this reaction. You don't have to write the notes because I'm going to send you the notes the way they are, and you write in your revision book. We are just revising for today, but in the next lesson, we shall be doing another thing. We shall be doing sulfur and its compounds, which we had not studied at school. Let's move on. Now, I bring you here. This is the most important reaction of carbon, I told you, with calcium hydroxide. With calcium hydroxide. I told you when I say describe the what is this, okay, state what is observed when carbon dioxide is bubbled through a solution of calcium hydroxide. Calcium hydroxide, this is what we call the lime water. But lime water is just like a nickname, like a botanical name, a nickname. Just like you yourself, you have a nickname. Yes, Mari, what's your question? I see your hand up. Before I proceed, what's your question? Mari? So I'm having a problem with some of you who have failed to connect your audio, and they have failed to connect their audio, and therefore they cannot hear me. I sent a message. I sent a message to you here and on WhatsApp telling you when you connect to Zoom, you must connect your audio on and your video on. If your audio is off, you will not hear me. Now I'm seeing two people whose audio is off, so that means they cannot hear me. But since I communicated, I hope they will run slowly. I hope they will run slowly. So let's continue. We were talking about this important reaction. We are talking about this important reaction of calcium hydroxide with carbon dioxide. Now, with limited carbon dioxide, when carbon dioxide is not excess, we form a white precipitate. And this is what you always say, that lime water turns milky. This is what you always say, that lime water turns milky. So with limited carbon dioxide, we form a white precipitate. And what is that white precipitate? Let's look at the equation. This is calcium hydroxide. When we add carbon dioxide, we form calcium carbonate. And calcium carbonate, this is the white precipitate. Because you remember, calcium carbonate is insoluble in water. So if it is insoluble, it will form a white precipitate. And the white precipitate is there. So this is the observation, a white precipitate. Now, I'm explaining my observation by saying the white precipitate is due to formation of calcium carbonate, which is insoluble in water. So I give you a mark for naming that the white precipitate is calcium carbonate, and I give you the other mark for saying that it is insoluble in water. That's why it forms a white. We are saying, however, that when excess carbon dioxide is bubbled through, the white precipitate dissolves, forming a colorless solution. When excess carbon dioxide, when you continue to bubble carbon dioxide in this solution, this white precipitate of calcium carbonate here will dissolve, and it will form a white, and it will form a colorless solution. So this is our colorless solution, and it is very important, so it is a marking point. What is that colorless solution? The colorless solution is due to the formation of calcium hydrogen carbonate. It is due to formation of calcium hydrogen carbonate, which is soluble in water. So calcium hydrogen carbonate is soluble in water, but calcium carbonate is insoluble. So our equation is there. So this question alone, when I say state and explain the observations that take place when carbon dioxide is bubbled through calcium hydroxide, it can cost you more than 5 marks. Can cost you more than 5 marks. Look, 3 marks are for equation, then whatever you have underlined is half a mark, so you can count yourself. Let us look at another reaction with sodium hydroxide. Now, the reaction with sodium hydroxide is the opposite of the reaction with calcium hydroxide. Many of you usually confuse this, so I want you to get it clearly from here and never to make a mistake again. Never to make a mistake again. So, with calcium, I mean with sodium hydroxide, I'm saying in limited carbon dioxide, there is no observable change. So on calcium hydroxide, in limited carbon dioxide, there was a white precipitate, but for sodium hydroxide, there is no observable change. This is due to formation of sodium carbonate, which is soluble in water. Now remember, all carbonates are insoluble. That's the solubility rule. All carbonates are insoluble except those of sodium and potassium. Those ones are insoluble in water. I mean, those ones are soluble in water, but all the other carbonates are insoluble. So there is no observable change at first due to formation of sodium carbonate, which is soluble in water. And I write my equation for 1.5 marks. It is there. Remember that the valence of carbonate radical is 2, so I need a 2 there. Now, however, in excess carbon dioxide, a white precipitate is formed. Oh, I forgot to underline this. This is a marking point. A white precipitate is formed. And what is that white precipitate? The white precipitate is due to formation of sodium hydrogen carbonate. It is due to formation of sodium hydrogen carbonate, which is insoluble in water. It is due to formation of sodium hydrogen carbonate, which is insoluble in water. So sodium hydrogen carbonate, for it is insoluble in water. And when you write your equation, you have to give it the state of a solid. Give it the state of solid. Yes, and don't forget to put these two to balance the sodium hydrogen carbonate. Now, let me also remind you of the uses of carbon dioxide gas. Now, most of the time when we ask this question, we don't just ask, we tell you to give the uses of carbon dioxide gas. We tell you to give us the uses of carbon dioxide gas, properties. You give the uses of carbon dioxide gas basing on the properties. For example, you will say it is used as a fire extinguisher. Can you be able to tell us why it is used as a fire extinguisher? That's a question. Why is it used as a fire extinguisher? Why is it used to extinguish fire? The reason is, or the property, why it is used to extinguish fire is that because it does not support burning. It does not support burning, and it is denser than air. It is denser than air, meaning it will displace oxygen. It will displace oxygen from the air. It will displace oxygen from the air. And if it displaces oxygen which supports burning, then burning will stop. So that's the reason why it is used as a fire extinguisher. It is used in the manufacture of preservative drinks. These drinks that are preserved, for example, soda. When you open soda, there is that first sound that you hear or that you see, and you see the bubbles of the gas coming out. That gas is carbon dioxide. Why is carbon dioxide used to preserve such drinks like soda? The answer is, or the property why it is used is because it has a pleasant taste. It has a pleasant taste. It is also used as solid carbon dioxide is also used as a refrigerating agent. It is used in fridges. Why? What property that is it that carbon dioxide is used as a refrigerant? The property is because it sublimes. Because it does what? Sublimes. Action of heat on carbonates, carbonates of sodium and potassium, they do not decompose when heated. So they are not affected by heat. Sodium carbonate and potassium carbonate, they are not decomposed by heat. All the other carbonates, they decompose on heating, forming a metal oxide and carbon dioxide gas. For example, when you heat calcium carbonate, it will give you calcium oxide, that is a metal oxide, calcium oxide, metal oxide plus carbon dioxide gas. So that's what we mean. However, we are saying ammonium carbonate for it sublimes when heated and forms ammonia, carbon dioxide gas, and water. So when you write the equation, ammonium carbonate when heated, it forms ammonia, carbon dioxide, and water. That's what I wanted to discuss with you today. And what is next is the assignment. We have like 5 minutes remaining. I will allow you to ask a question if it is there. You can now unmute and ask a question if it is there about what we have discussed. Otherwise, the lesson has been recorded, and for those who were on and off, I will send you the recording.
Yes, teacher.